If we know the value of theta, we can figure out the ratios for 2 theta. We have these identities for us. Sine 2x is 2 sine x cos x. So if we know sine x, we can figure out cos x, and using both of these, we can figure out sine 2x. For cos 2x, we have 2 cos square x minus 1, or 1 minus 2 sine square x, or cos square x minus sine square x. So if you know the value of cos x, we can figure out the value of cos 2x. And for tan 2x, this is what we have. We have tan 2x equals to 2 tan x by 1 minus tan square x. So if we know tan x, we can plug the value of tan x here and get the value of tan 2x. But can we do these things in reverse? If we know the values of tan 2x, cos 2x and sin 2x, can we figure out the values of tan x, cos x and sin x? That's the question that we'll cover in this video. Given ratios for 2 theta, can we figure out ratios for theta? Let's discuss some strategies. Let's look at this third equation. Tan 2x equals to 2 tan x by 1 minus tan square x. Imagine for a while that you don't know the right hand side, but you know the left hand side. We can write it like this. A equals to 2y by 1 minus y square. We have two different things here, tan 2x and tan x. So if we know A, can we figure out y? Think about it. Yes, we can, because given A, we can rearrange this and this will become a quadratic. We can solve the quadratic for y. So what this means is we can do this in reverse for tan 2x. If you know the value of tan 2x, we can use this identity in reverse. It's just that it'll take us a little longer because it's going to be a quadratic. What about cos 2x? If we know the value of cos 2x, we can figure out the value of cos x using this formula, 2 cos square x minus 1. If cos 2x is a and cos x is y, a is equal to 2y square minus 1. And you can rearrange this, you can figure out the value of y. You can also find the value of sin x using cos 2x, because sin x and cos 2x are also related. You can say that cos 2x is a and sin 2x is z. So a equals to 1 minus 2z square. Cos 2x equals to 1 minus 2 sin square. So if you know a, we can figure out y, we can also figure out z. So given cos 2x, we can solve for cos x or sin x, we can solve for either of them. What about this third one? When you have sin 2x, well, if you know the left hand side, it's slightly difficult to figure out the right hand side. Here we have two things that we don't know. We don't know sin x and we also don't know cos x. If we assume one of them, let's say we assume sin x as w, cos x will be square root of 1 minus w square, and the equation becomes a little messier. A equals to 2w square root of 1 minus w square. It's solvable, but it's going to take a lot of time. So here's the recommendation. When you have to find tan x, use tan 2x. This is recommended for tan. And when you have to find sin x or cos x, use cos 2x. Once you have tan, sin or cos, once you have any one of them, you can form a triangle and find the rest of the ratios. Let's do this. Let's practice this using a problem. Find tan of pi by 8. So we have a new angle with us, pi by 8, and we want to find the tan of pi by 8. How do we approach this? Pause the video, try this on your own. Okay, let's do this together. Pi by 8 is half of pi by 4, and we know ratios for pi by 4. That's 45 degrees. So let's use them. Step 1 will be to find the relevant double angle. Double of that is pi by 4. So we don't have to think too much about it. Pi by 4 is 2 theta if pi by 8 is theta. Now let's apply tan on both sides. Tan pi by 4 is equal to tan 2 theta. On the left side we have 1 and on the right hand side we have tan 2 theta. We're looking for tan theta, not tan 2 theta. So let's open this using the identity. Tan 2 theta is 2 tan theta by 1 minus tan square theta. This is equal to 1. Let's rearrange this. 2 tan theta equals to 1 minus tan square theta. Now this is a quadratic in tan theta. Next step will be to solve the quadratic. Let's assume a variable here. Let's assume tan theta is x. So this is 2x equals to 1 minus x square. Rearranging, x square plus 2x minus 1 is equal to 0. Now we can solve this quadratic. We can use the discriminant formula. D is equals to b square minus 4ac. 2 square minus 4 times 1 times minus 1. That's 4 plus 4. So d is 8. Square root of d will be 2 root 2. And then we can find the value of x. So x is equal to minus b, which is minus 2, plus minus root d, which is plus minus 2 root 2, divided by 2a, which is just 2. Cancelling this 2, we have x is equals to minus 1 plus minus square root of 2. Now because this is the quadratic, we're getting two values, but one of these values is not correct. Can you figure out which sign works here and which sign doesn't? Okay, let's do this together. Step 4 is making sense of the solution. We're getting two values because we're solving a quadratic, but only one of these values makes sense. So let's think about it. One value is minus 1 minus root 2 and the other one is minus 1 plus root 2. Minus 1 minus root 2, taking the negative sign, gives us x as a negative quantity. X is tan theta, which is tan pi by 8, which is not a negative quantity. Pi by 8 is in first quadrant, that's 22.5 degrees, and tan in first quadrant is not negative, it's actually positive. So this is an incorrect value. The correct value is minus 1 plus root 2. This gives us a positive value. So tan pi by 8 is minus 1 plus root 2 or root 2 minus 1 because our angle is in the first quadrant. So tan pi by 8 is root 2 minus 1. So this is how we have moved from tan 2 theta to tan theta. And now that we know the value of tan, we can figure out the value of sine and cos. I prefer forming a triangle. We can use different identities, but visualizing sides makes most sense. If tan of an angle is root 2 minus 1, which this means perpendicular by base is equal to root 2 minus 1. So let's assume that we have a right angle triangle. This length is root 2 minus 1 and this is 1. If we apply Pythagoras theorem here, we can get the hypotenuse. So we'll get all three sides, which means we can get all sorts of ratios. So let's do that. Let's assume that this side is y. So y square equals to root 2 minus 1 square plus 1 square. Opening the square will give us y square equals to 2 plus 1 minus 2 root 2 plus 1. This is 2 plus 1 3 plus 1 4. So y square equals to 4 minus 2 root 2, which means y is equals to square root of 4 minus 2 root 2. A lot of roots, but that's okay. So y equals to square root of 4 minus 2 root 2. That's our third side. That's our hypotenuse. This means we can figure out the sine as perpendicular by hypotenuse. That's root 2 minus 1 by root of 4 minus 2 root 2. And we can also figure out the cos. That's 1 by y. That's 1 upon square root of 4 minus 2 root 2. So this is how we can move from the ratios of pi by 4 to the ratios of pi by 8.